Hi guys, Evan here. Today we're covering PT 36 Game 1, but more importantly we're focused on how to keep things organized when you're tackling a lot of conditional rules. Of course you have to chain them together, but more importantly perhaps is making sure that those chains are nice and organized so that you know where to do your inferences easily and quickly when you're actually doing the game. So we'll go over that process. I'll actually show you an alternate way that you could do it, but it's not my recommendation. And hopefully you'll see that the way I recommend is better. Okay, so this is a basic in and out game. We have 6 variables. They're either selected, carried by the stand as it were, or they're not. That puts them in the out group. So things are going to either be carried by the stand and they'll be on this side, or out, not carried by the stand, and they're on this side. Here are our variables F, K, O, P, T, and W. Okay, here we only have conditional rules. That's actually fairly typical of in-out games, and you get a bunch of them, and you should always be looking for how they link up. Anytime I see that it's an in-out game and that there's a lot of these conditional rules, I'm going to use this technique to keep them organized, and I call it the 2 chains technique. So what we do, first start with the dividing line between where you're going to put the rule, the original version, and then the contrapositive on either side of this line. So we get our first rule here that if the stand carries K, then it does not carry pairs. So I'm going to put the original of that up on the top line, K, then not P. And now on the other side, I want to put the contrapositive, P, then not K. Nice, easy way to keep things organized. We're going to use these as the base of chains, right? A lot of people, when they do these games, they'll just write the rule in their contrapositive. They'll write K, then not P, and then do the contrapositive. And then even if they get more rules that link up with this, they don't chain them together. They'll just keep writing rule 2 and then its contrapositive, then rule 3 and its contrapositive, not seeing that you can link these things up. When you're doing inferences, it's super important to chain them up, as you'll see when we solve these. It makes it so much easier to see the consequences of something happening, a given thing, say K being selected. For the next rule, if the stand doesn't carry T, then it does carry K. So not T, then K. And I'm putting it off to the side for now. When you're good, you don't really have to do this. You can just add things straight to your chains. But see this K. Where does that line up? Right here. So not T, then K. I just add it to my existing chain. And then the contrapositive, not K, then T. I can add that right here. We get these match up, right? So I can add that just like this. T. Okay, now we just keep going with the next rule. Again, I'm going to put it off to the side to start just to make it easier to see what we're doing. If the stand carries O, then it carries both P and W. So O, then P and W. Look for any like terms that you already have in here, and I see P and P. So I can add the rule on neatly right here. O, then P and W. And this looks like it's kind of just working out by magic, right? But that's the way the game makers intend to do it. They intend that these rules are going to link up like this. So it's not surprising that they do. If you had one that doesn't link up with anything, what I would do is leave it off to the side and see if it links up later. And if worse comes to worse, you can just leave it unconnected to your chain. The contrapositive here would be not P, or making sure to change that operator, not P or W, then not O. And then the last rule, if the stand carries W, then it carries F or T or both. So W, then F or T. I don't write out or both because I always assume that ors are inclusive. If you'll remember from earlier lessons, anytime you see an or on the LSAT, you should assume that both is possible. So I just want to add this to my existing chain. I see where anything matches up. Oh, here's the W. So W, then F or T. And then the contrapositive is going to be not F and not T, then not W. Adding that contrapositive right straight in. Again, it looks like it works out perfectly, but every time you can add, the original statement on one side, you can add the contrapositive on the other side. Now you've got these two chains that are just incredibly easy to work with. Say I tell you that T is out, like T is over on this outside. I just look for T being out here, and I can tell every consequence of that. It's nice and easy to see. Now I know that K's in, P's out, K's in, and O is out. Boom. Very, very easy. Always be careful, of course, to make warranted assumptions. Like this rule here, P, not P or not W, then not O. That gets triggered if either one of these sufficient conditions occur. P or W being out, then that triggers this. So be careful to make the same warranted assumptions that you learned how to do in the lessons on complex conditionals. But again, it's super easy. So that was an example with T being out. What if O's in? Then I know P and W are in as well. P and W, right here, right here. I know that we need F or T or both. I know that K's out and T is in. So T is definitely in. F might be in. But look at all that information that I got, and look at how quickly and easy it was to get. Now, if you only had one chain, you could still do all this, but you'd have to work backwards. Like if I tell you O is in, you'd have to look here and work by modus tollens. Imagine this chain is totally out, is what we're doing here. You'd have to work backwards. Like, okay, O is in. Okay, and what's the modus tollens inference here? You have to think about it pretty hard to do that. You have to be like, okay, it would be P and W are in now. And then it would trigger the opposite of this, which means that F or T are in. Working backwards on the chains is really hard. I think it's so much easier to work forwards only doing modus ponens inferences. And having both these chains allows us to do that. Anytime I get the information, I just look for the exact same thing in the chain. O, I just look for O, and then I work forward with the arrows. If I see not F, I just find not F and work forward doing only modus ponens inferences. That works because if you recall, when you take a rule and the contrapositive of that rule, so A, then B, for example, not B, then not A, and I were to give you a piece of information, okay, say A is in, well, that triggers this rule right here, right? And then we would know that B is in as well. Or we could do it via modus tollens down here. A is the same as, not A, and therefore we know not B, therefore B. So that doing the modus tollens inference on the contrapositive gets you the same inference as doing the modus ponens one on the original, right? So that's why these chains are just mirror images of each other. They're the same exact rules, just expressed differently. However, it's much easier to always work forward with the arrow. And you'll see that's all we do throughout this game. All right, and once you have this, solving the game is almost just an afterthought. With these chains, it's just so easy to work with. We'll skip question 1 because it's just the acceptability question and move on to 2. Which of the following could be the only kind of fruit the stand carries? So we need to find something here that doesn't trigger anything else being in. So, if T is in, say, it doesn't pull anything else in. So looking at the end of the chain is the easiest thing to do. If T's in, there's nothing else that happens. There's no arrow pointing anywhere to any other thing being in. So it could just be tangerines. Whereas anything else brings other stuff in. Say P's in, you look at that, that's going to bring T in as well. The reason being if P's in, K's out, and then when K is out, T is in. So P brings in T as well. But T doesn't bring anything in. It could be the only fruit, and that's the right answer. So D. These chains just make things so much easier to work with. For 3, we're looking for something that cannot be a complete and accurate list of the kinds of fruit the stand carries. So, you can just try these out really quickly. K and T for this first one, they don't bring anything else in, right? K's in, it doesn't bring anybody else into the stand. So K, so that's fine. T, we already know, doesn't bring anybody else in. So this could be a complete and accurate list of fruits that are in. Cross A off, and you just repeat this process. Tangerines, watermelons. Yeah, watermelons bring in F or T, but you've got the T in, so you're good there. Cross B off. How about F, K, W? Again, with this one, you should already know. W, that's going to bring F or T in. We've got the F, so that's good. K doesn't bring anything in. By the way, K could have been the other answer to 2. If K, if they didn't have tangerines as a possible answer, K could have also answered it because it doesn't bring anything in. Anyways, this one doesn't help us. We're looking for a list that could not be the complete and accurate list. Move on to D. Oranges, pears, tangerines, watermelons. Does any of these bring anything else in? W is in, but we've also got the T, so we meet that requirement. P brings in T, T's already there. O brings in P, W, T, and one of F or T. That's already met. So this meets all the requirements. We now know by elimination E won't be able to work, so you can check what it does wrong. F, K, O, P, W. The issue here is that if K's in, O has to be out, right? It triggers P being out. Oh, and both P and O would have to be on the outside whenever K's in. Okay, 4, we have watermelons out. So watermelons on the outside, we just look for that. That means oranges is out as well, following this rule here. If oranges are out, we don't get any other information. So really there's not much else we can figure out besides this. So I'm looking for something that must be true here. The stand carries kiwis. I look at that. It doesn't look very promising. Why does there have to be kiwis in? That wasn't an inference we could make. Stand carries at least 2 kinds of fruit. Feels like we could throw tons of stuff out, we could have not T, have K in, and then P's out. Only one kind of fruit. What's left here? We could throw F out as well. So you could have just one kind of fruit. So we cross off B as well. What about the stand carries at most 3 kinds of fruits? O and W are out. I think you probably can't get all 4 of the rest of the fruits in. Let's just try it. Yeah, and when we put K in, that means P has to be out. So having 4 in this situation would break the rules. So there's at most 3 kinds of fruits. 4 is no good. Okay, for 5, if the stand carries watermelons, which one must be false? So watermelons are in, then we know that either F or T is in, or both. So an intuition I had here is that I might look for something that then, has to be false because it would mean both F and T are out. We know we need to have one of them in. So if we're looking for something that must be false, we're going to look for something that breaks this rule that when W's in, F or T have to come in as well. So I scanned through and I saw, okay, well, we've only got a couple that deal with F or T. A and B don't check out because you could have just one or the other. But what about E? The stand carries pears but not tangerines. So T's out, F is in, but it carries pears. The problem with that is if pears are in, T has to be in. So you can't have that, right? You can't have pears in and T out. So E must be false, and it's our right answer. For 6, we're getting rid of a rule. we're kicking out the not T then K and the not K then T rule. Then you just have to find a list that couldn't be a complete and accurate list of the kinds of fruits the stands carry. I think I would just do this going one at a time by elimination. Here you get to C and orange, pears, and watermelons, O, P, and W. The problem with that is if O, P, and W come in, even with this rule gone, you have to have one of F or T, right? O brings in W, which then brings in one of F or T. So C doesn't work out. Okay, so that's the game. It gives you an idea of what it's like to work with these chains of rules. This game would have been incredibly hard if you had to do MT, modus tollens inferences. But because we have both chains, the game's pretty easy. And it kind of gives you an idea that if you don't do this, you're really swimming against the current. This is how the LSAT intends for you to have this written, I think. And that bears out by how much easier it makes to solve a game that should be pretty easy. This is the first game in this section. If you do it this way, you're going to get this game done in like 6-7 minutes. If you don't, I think it's going to take a lot longer. Okay, if you didn't feel like you were very solid on the concept of making the two chains, don't worry. As we do these in-out games in the game walkthroughs, we'll always use this technique to organize our conditional rules. So just keep observing how we do it until it sinks in for you. Remember, it might make things easier if you write the rules off to the side before adding them to your chains. Okay, thanks. We'll catch you on the next lesson.